Okay, so today you just have to do a few problems with wavelength, frequency, amplitude. I want to remind you that amplitude tells you how loud a sound is and how bright a light is. I want to remind you that frequency tells you the color or the type of light or the note for a sound wave. There are certain sound waves whose frequencies are assigned a letter note, and they are things like middle C at 256 hertz, middle D at 288 hertz, and then so on right down the different notes. And I want to remind you that when you get to C again, you've gone up one octave, and that's a doubling of the frequency. I want you to remember that humans cannot hear all sounds. Ultrasound is sound higher in frequency than what we can hear. I want to remind you that we cannot see all light. Okay, so there's lots of colors that we cannot see, and those are things like radio, microwaves, X-rays, gamma rays, ultraviolet, infrared. Okay, if you don't have this sheet, you're going to need it today, so you might want to take a picture of this table to use for today. I want to remind you of the formula that we found in lab. Wavelength, which means the distance, right here, the distance between two adjacent waves. That should be measured in meters. I want you to remember frequency is caused by the thing making the sound or light. It's the frequency of the tuning fork, how quickly it vibrates. That should be measured in hertz. And finally, velocity is how quickly the wave is moving. That should be measured in meters per second. And that is determined by what material the wave is traveling through. Here are the problems you have to do today. So the first one, I'd like you to find the wavelength of middle D, which is 288. When the temperature is 25 degrees Celsius. So this is a sound wave. So go back in your notes and find the formula for the speed of sound at different temperatures. Use that speed along with the frequency to find wavelength. You're not being graded on your correct answer. Show me all your steps. Some of you are failing these things because you're not showing me formula, numbers you plug in, answer, and units. Again, if the answer is wrong, that's okay. So long as I can follow your thought process, that's the more important thing. I want to see how you are thinking about solving these problems. Put your picture right here of your work. Try to make it look neat. I've been taking off points for people who have not been taking the time to make these things look presentable. Problem number 2, you're going to deal with echolocation for bats and for dolphins. With the bat, you're working in air, and you can use a temperature of 20 degrees Celsius. For the dolphin, he is in salt water, so please look up on your reference sheet the value for the speed of sound through salt water. Okay? You're trying to find the wavelength of these waves because that helps determine how much detail the bat or the porpoise can learn about the target that's being hit by their sound waves. Humans do the same thing, not to find prey, but we use sound waves to actually look at things inside the human body. These are called ultrasounds. You can look at a fetus developing inside a human body, you can look at the heart, you can look at kidneys, you can look at all kinds of internal organs. And I'd like you guys to find the wavelength of these ultrasound waves. Why is that important? Because the smaller the wavelength, the more detail we can see with it. So if you have a low-end ultrasound, it's at 2.5 megahertz. And if it's a high-detailed ultrasound, it will be at 15 megahertz. Find for me the wavelength in both cases. The speed of sound through human tissue is around 1,540 meters per second. This next one, you don't have to show me any work. You just have to put your answers in the box. For wavelength, measure the distance between two adjacent waves. Again, 100 meters is 10 little boxes. Then calculate the velocity. You don't need to show me the calculation. It's pretty simple. Just make sure you put your answers in red in the box for full credit. The final one I'd like you to do is a laser pointer. And with my cats, I have a red laser pointer. This happens to be a green laser pointer. It tells you the wavelength, 532 nanometers, and I'd like you to use that to find frequency. When you do this problem, you're using the same formula, but this is not a sound wave, this is a light wave. And for the speed of light, you can simply use the speed of light in outer space. You don't have to worry about the fact it's in air. Okay, so that's all you got to do. 5 problems. Hopefully they're pretty easy. When you're done them, just share the slideshow with me. And I wish you guys a great weekend. This will not be due until Sunday night at midnight. So if you have things you need to take care of on Friday, just get it done sometime over the weekend. Again, I'll see you on Monday.